First thing we're going to do is, this is not on your notes because this is a warm-up, and I didn't want to print all this stuff out. So hopefully you can read these little tiny, which I already made bigger ones, these little tiny equations. If not, hopefully somebody at your table can read that for you. But I want you to take a minute or two. You can discuss it with the people at your table, either your shoulder partner or all of you, however you want to do that, depending on how many of you are here today. And I want you to see if you can match up the graphs to the functions. Ready, go. You have to actually look at them. And you can write them down, you can draw, you can do whatever you need to do with your markers. All right, we think we got it? All right, so let's talk through this, because some of you may not even be sure exactly how to think through this. The first thing I would look at here is my b value, okay? So this b value, does that mean that that is exponential growth or decay? Growth. So strictly on the 3, I know my graph looks like this, right? But then I have this negative sign here, which means I'm going to have a reflection in what? In the x-axis. So when this flips down here, which one do I get? B. Okay. I don't know why I circled it, because I'm going to end up circling all of them, but right, we good with that? That's one way to reason through it. So when I look at this right here, that again is exponential growth, right? Do I have a reflection? No. So that means that is A. Now, I do have this 1/2 and this 4 here that we ignored, but all those are vertical stretches and compressions. It's not going to change which way things are facing, right? Make sense? Okay, so number 3, based on this B, growth or decay? Decay, which means it looks like that. Is there a reflection? No, so that makes this D, right? Except this one right here. This means it is what? Decay, so it looks just like this, but then I have a reflection, so the reflection means it looks like that, and that would be C. Okay, we all okay with all that? Okay, beautiful. All right, now, we're going to write limit statements here, but what I really want you to do before we start is on 5 through 7, I want you to do a little sketch of what it would look like, so it looks like this or like this, okay? Just quick little sketch, draw them out on your table for 5, 6, and 7. Because if you can't write the limit statements if you don't know what it looks like. Only 5, 6, and 7. All right, so on 5, this 4 means it's exponential growth. The 3/5 doesn't really affect it affects the graph, obviously, but when I'm doing this rough sketch where I don't even know what any numbers are, that doesn't do anything for me. And I have no reflections, therefore my graph looks like that. We agree with that one? Okay. So then on 6, This, again, is exponential growth, which starts off looking like that, but then I have a reflection, so it ends up looking like that. We agree with that? Okay, and then this is exponential decay, so it looks like this. No reflections, so that's my graph, right? So again, the question was really asking for limit statements, so we're not going to write them all out, but I need this to be able to write my limit statement. So if I was going to go back and write a limit statement and say, okay, the limit as x approaches negative infinity of f of x is what? 0. This graph is approaching 0, right? The limit as x approaches infinity of f of x is infinity. Okay, we good with that? Number 6, the limit as x approaches negative infinity of g of x is 0, and the limit as x approaches infinity of g of x, negative infinity. Here, as x approaches negative infinity, what does y approach? Infinity. As x approaches infinity, y approaches 0. Good. Y'all got that? Perfect. This is just asking growth or decay, which I asked on all of them, so we don't need to do that. All right, perfect. So then let's grab our notes. Oh, that is not the right thing. What the heck? There we go. And this is going on page 61 when we're done. Okay. So we're not going to finish all of this today. We're actually going to skip this first part. And we're going to start here today, and we're going to come back and do that tomorrow. Okay? So when we want to model exponential functions from data, okay, we can do that if we're either given a common ratio and the initial value, we can figure out what to do with that, or if we're given two input-output pairs. Okay? And then we can find the initial value and the base or the common ratio. Right? So let's look at example 2. It says for t being between 0 and 30 minutes, the number of fans inside a large sports stadium can be modeled by the exponential function, and then they give me this function right here. And I can tell you that on that exponential function, there are no vertical translations and there are no horizontal translations. There's also no horizontal dilation, but A means I could have a vertical dilation, right? We good with all that? Understand where all those pieces go? All right, where F represents the number of fans inside the stadium and t minutes after the doors open. Okay, so there are 47 people in the stadium 2 minutes after the doors open, 2,602 fans 20 minutes after the doors open. It says use the given data to write two equations. So I'm going to write two equations that can be used to find the values for A and B. Okay, so it doesn't even tell me to find them. It says write two equations that could be used to find them. So by doing this, you have to make sure, this is helping you make sure you understand what the heck is going on in any of these equations. If there are 47 people 2 minutes after the doors are open, t is 2, right? And it goes in right here. So f of 2 would be equal to some a times a b that I don't know to the t power. But in this particular case, what is t? 2. And what should that equal? 47. Very good. Because f of 2 equals 47, I know I can substitute t in for t right there, or 2 in for t right there. So then I also know that f of 20 would be equal to a that I don't know times b that I don't know to what power? 20. And then what would this equal? 2,602. Okay. So I like that they asked the question this way because it's really making you think, what is t? Where does it go? We don't know the a and the b, right? So we're going to figure that out. And I know this question doesn't even ask that, but we're going to do it anyway. So turn your calculator on and get to this screen. 1 for new, then no. And we're doing regression here, so what number do I pick? 4, right? I'm adding lists and spreadsheets. I got to add my stuff in there. 4. So I get this. I'm going to arrow up twice, type in xval. What are my x values? 2 and 20. Yes. And I only have 2 of them, but that's okay. And over here I have y value. And those are 47 and 2602. Okay. Any questions at this point? Close your computer, please. All right. So I want to do my regression here. What button do I push next? Menu. And then 4 for statistics, then 1. All right, what kind of regression am I doing? Exponential, right? We're doing exponential, so way down there at A, you don't have to arrow down or anything, you can just hit A. Then this looks just like when we did the other regressions. Change this to your X value, change that to your Y value. Where is it going to store it for me? F1. And we hit enter. Okay. So it shows you on here your regression equation and what the A and B look like when you put them in. Then it gives you the A, and it gives you B. And notice when I click on it, does that do that for you as well in your calculator? Okay, good. Just curious, because sometimes up here it works differently. But like if you can only see 1 decimal place, if you actually click in that cell, you can see a whole bunch more so that you can get the 4 that you need. Okay. So over here, let's just write down our A and our B. So A is equal to 30.0890. And B equals 1.2498. And sometimes you might just be asked for A and B. Sometimes you might be asked for the equation. Sometimes you might be asked for the equation and do other stuff with the equation. It just depends on the question. Okay. What questions you got for me? We good? If you can do regression in one, you should be able to do regression in anything. Okay. All right, so then let's look at this next one. Selected values of the exponential function g are shown in the table above. And again, it's telling you this. Pay attention when it shows you that, just in case it looks different than what you're used to. It says use the given data to write 2 equations that can be used to find the value. So it's asking us to do the same thing we did up above first. So that means I know that g of 3 is equal to a times b to what power? 3. And what does that equal? 21.54. And then g of 8 is equal to a times b to the 8th, 3.62. Any questions about where any of that stuff is coming from? Okay. All right, and do you think this is growth or decay? Decay. Sounds good. So now it asks us for the values of A and B. So that's pretty much what we just did up there. You go forth, push buttons on your calculator. Make sure you know how to get there. So I'm going to hit my on key. Always just start with a new one. 1 new. No, I don't want to save. 4, and go from there. Let me know if you get lost in something or you're not sure what to push or what's going on. And it's fine if you have a question. It's fine if you ask your neighbor, but don't feel like you can only whisper to your neighbor and not ask me something. Double check yourself with me once you get it. Let me know if you have questions or you got something way, and if you did get something way off, make sure, just go back and look at your numbers, make sure you type them in correctly, because that can totally be something that happened that anybody's capable of. We all good? Yes? Beautiful. All right, flip it over then. All right, so now we're going to talk about the natural base E. E is a number, just like pi is a number. We usually use the pi symbol because pi is how many digits does pi have? An infinite, right? And E has an infinite amount of digits. That's why it has a little squiggle, like it's about 2.718. Now, you should have in your brain that, just like you know that pi is about 3.14, I think for you to know that E is at least about 2.7-ish is good for you to be able to reason through some things. But I'm going to show you a quick little video. It might just be like a minute or two. It's like super short. But it just kind of gives you a little idea of what E really is. So hopefully my speaker stayed on because it doesn't always happen.
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous but equally fundamental number known to anyone who's taken high school algebra. It's about 2.7182818828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So if you stick $1 into a bank account with 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
Okay, so I feel like E, I know this is not the first time you've ever seen it, but it is something that when you first start using it, whoever taught that stuff to you may not even have attempted to explain to you what it is, because when you very first start using it, it's probably really not going to make a whole lot of sense. It still may not make a whole lot of sense to you, but just know that it's not a number that somebody just made up, okay? Euler's the one that kind of got credit for it, and that's why it's also can be called Euler's number, but it's E, that's what his name starts with. I know that you've seen the PERT formula before when you're talking interest, P times E to the RT. That look familiar? Like you've seen that, right? So you use E in that, you use E in a whole lot of things. We're gonna use E right now talking about bacteria, okay? And we don't have to know how to create these formulas, but just know that E, you can do a whole deep dive on E if you want to figure out what's really going on with it. But let's look at this example. It says, the number of bacteria B in a particular culture can be modeled by this exponential function. So they give us B of T, where T is measured in hours. Okay, so T is measured in hours, and we have the number of bacteria in a particular culture. So then they give us A of T, right? It can be, so A of T, which is this right here, is an equivalent expression for B of T. And I want to find the value of little b. Okay? So they're telling me I have these two different equations. They represent the same thing. On this one right here, I don't know what A or B is. But if they're the same, then I know that A of 0 has to equal B of 0. You agree with that? So A of 0, if I put 0 in here, this is going to give me A times B to the 0 power. And B of 0 will give me 17 times E to the 0.31 times 0 power. Okay. So what is B to the 0 power? 1, and 1 times A is A. Well, 0.31 times 0 is 0. What is E to the 0 power? 1. 1 times 17 is 17. So A is 17. I know that for A of T, this would give me 17 times some B that I don't know to the T power. Everybody okay with that? And all this asked me for, well, it asked me for A. Now I got to find what B is, right? So let's take this one. Let's take B of t, and let's rewrite it at, like we were doing on Friday, 17. Let's change that power to a power here. E to the 0.31 to the t power. Is this the same thing as it was over there? Right? I just split up my power to a power. Remember we were doing that with the horizontal stuff? Because if I multiply 0.31 times t, I get this. So it's just a different way of writing it, right? And so when I look at these two here together, what does B equal? E to the 0.31 power. What questions you got? We good? Do I care what that number actually is? No. Do we know what that number actually is? No. Is it going to be a nasty decimal? Absolutely. Okay. All right. So now we are going to find the average rate of change of B of t on this interval. What does the average rate of change mean? Slope. Average rate of change is slope. It is the change in y over the change in x. And I want to make sure that I find the average rate of change of the correct thing. I want it of B of t. And I know what interval it is. So my slope is going to be whatever the y value is at 7 hours. So that's B of 7 minus B of 1 over 7 minus 1. Now, B of 7, do you think that's going to be a nice, pretty number like 25, or is it going to be like a crazy, ugly number? If I substitute 7 in here, it's probably going to be a crazy, ugly number, right? So it's not something I want to do by hand, and it's not a decimal that I want to write down, okay? But if I am asked for the rate of change, I have to show a difference quotient like this. I have to show this. I cannot just push buttons in the calculator. I do not have to write down any other numbers besides the answer, but you have to show that you were actually finding slope. You with me on that? Now, I don't want to have to type in this thing twice to get these two. So if I don't want to have to keep typing it in for the different ones, where do I put this equation so I can get an infinite amount of answers out? What part of the calculator? The graph, exactly. So let's hit the on button, and let's go to new. And no, I don't want to save it. And I'm not doing regression this time, and if I'm not doing regression, I hit 1 for add a calculator, and then I also add a graph. So in my graph screen, Bianca, you with us? In my graph screen, I'm going to put that B of t formula, which is 17. E is right here on the row with 1. E to the 0.31. Do I get to use t? No, I have to use x, right? Everybody okay with that? All right, so then I'm going to hit enter. Now, that's all I see of the graph, and that's fine right now. I don't really care. Because what I really wanted to do was use the calculator part of it anyway. So what I'm going to do in the calculator is this, basically. But I don't put B of 7. What do I put instead of B of 7? F1 of 7. Good. So back over here, I want to start with a fraction, so I'm going to hit Control Divide. Then I'm going to do F1 of 7. Oh, that's just a 1. That doesn't work. F1 of 7 minus F1 of 1 divided by 7 minus 1. I'm not even going to put 6. I'm just going to put in exactly what I had. Then I'm going to hit enter. Okay. Then I write down how many decimal places? 4. 9, 5, 2, 1. But I need units. This is slope. It is y over x. You go back to the question. You grab your units for y. What is our units for y? Bacteria. Number of bacteria or bacteria. So bacteria And what is our units for x? Hours. So this would be blah, 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 bacteria per hour. Okay? Even if you don't understand what it means or whatever, you grab y, put it in the numerator, grab x, put it in the denominator, move on with your life. Okay? What questions you got? All right, good deal. So now this says, find the number of bacteria, find the number of bacteria B predicted by the model, okay, after 1.5 hours, or I'm sorry, not 1.5, 15 hours. This is T, right? I have T, I want B of T. So B of 15, because that's where we put our T, right? We're going to go to the calculator. Where in the calculator would I go for that? F1, back over here, right? And just do F1 of 15, right? And you should get 1777.9447. 447. What are my units here? Bacteria. Okay, we're going to add a question in here. So I'm going to you should have some room, hopefully. Here's what we're going to do. We're going to find T when number of bacteria is 1,000. Okay, we're going to find T when the number of bacteria is 1,000. So on this one, they gave us T, and we found B of T. Here, we have B of T, and we want T, right? Find T. So what is another way to say B of T? What part of the graph does that represent? Y. So basically this is saying y equals 1,000. What is x when y equals 1,000? That's what it's asking me for. You with me on that? So I'm going to go back to my calculator. I actually want the graph screen. So I have one function in there. I need to type in y equals 1,000. So I hit tab. That'll put me in F2. Well, tab, F2, 1,000. I hit enter. I'm very not impressed because I see nothing. Does it make sense that you don't see anything? Right, yeah, right? So we just typed in that y was 1,000. This only goes to 6.67. So we need to change our window. So I'm going to hit menu. Then what do? Where do I go to change my window? 4. And then 1 for window settings. So my y, I know I need to go to at least 1,000. Let's go y max 1,100 so we don't go crazy. I know that'll be on the other side of it. I hit enter. Okay, well, here I can see my new line now, right? And I can see this function, but I can see that they intersect over there. Do I have any way of knowing where over there would be? Not really, right? So we're going to go back to the window. Number 1. Let's do our x max. Let's just double it and make it 20. Ah, and there we go. We can see something. Or I could make it 100 or whatever. But if you go too crazy off, you know, and if that hadn't worked, then I might figure out what a better number is. But what do I want to do with these two things? Find the intersection, because right here where they intersect, I know the y value of my bacteria function is 1,000, and I need to know what that x value is, right? So I want to find the intersection. So I do menu. What am I going to do then? 6 for analyze graph, then 4 for intersection, and then move it to the left side here. Click that inside button there, and then move it over there. Click that, and we got our intersection. Okay. So then that means that t equals 13.1436. What are my units? Hours. Very good. What questions do you have? Are we good? Okay. We're going to stop here today. Tomorrow we're going to do example 5, and then we're going to go back and do the beginning part of this. I'm going to go ahead and give you your assignment because I want you to get started on it with the last time that you have. The first part of the notes, the question's actually at the very end of the worksheet, so if you start at the beginning here, they will be calculator questions that you can work through.